Inertia is the tendency of an object to remain in a state of rest or uniform motion. Now, by state of rest, we mean an object that's not moving, and by uniform motion, we mean it isn't changing its velocity. This lack of change is why we use the term inertia, which is Latin for inactivity. Let's look at an example of inertial motion. Here we have a shuttle drifting in space. There's no gravity, no driving force, no drag. In fact, there's no forces at all. So by Newton's first law, since there's no forces, the shuttle must be moving at a constant velocity. Or in other words, it's moving with no acceleration, or it has uniform motion. This is an example of inertial motion. But there's another definition we need to know that involves this idea of inertia. Let's take a look at it. Inertial mass is a measure of how difficult it is to change an object's velocity. You'll need to be able to define both inertia and inertial mass for your exams, so make sure you don't get these definitions mixed up. Let's see what this means with an example. Suppose we have two stationary balls, one made of wood and one made of metal. If we did this experiment for real, we'd probably want them floating in space, so there's no forces acting on them. Now let's suppose we apply the same force to each, and for the same period of time. The force will cause both of the balls to gain some velocity. However, we notice that there is less change in velocity in the metal ball. There was no difference in the forces we applied, so this difference must be to do with the properties of the balls themselves. We call this inertial mass and say that the metal ball has greater inertial mass. But is there a way we can describe what inertial mass is mathematically? Well, we can derive a formula for the inertial mass of an object using Newton's second law. Remember that Newton's second law tells us that the acceleration of an object is proportional to the resultant force applied to it and inversely proportional to its mass. This can be written as the resultant force is equal to the mass times by the acceleration. Now, if we divide both sides of this equation by acceleration, we get that the force divided by the acceleration is equal to the mass. Using this equation, we derive that the inertial mass is equal to the force needed divided by the acceleration given. From this, we can deduce that in our previous example, the metal ball was given a smaller acceleration by the same force because it had a greater inertial mass. It's important to clarify that inertial mass is more of an application of mass rather than a separate measurement. You likely won't need to use this equation for calculations. It's more for helping to explain what inertial mass is. If you do need to calculate inertial mass, it will be just like using the equation for Newton's second law normally.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!